In this video, I will show you how to use the relationship between the length, area, and volume of similar figures to find unknown lengths, areas, and volumes. So for problem number 20, we have two similar triangles have an area of 49 square centimeters and 16 square centimeters. The perimeter of the larger triangle is 39 centimeters. Find the perimeter of the smaller triangle. So to start off with, for a length, area, volume problem, I find it useful to make a little chart, a scale factor chart for length, area, and volume. So this is where we will record our scale factors. So they're going to give us one of these scale factors somewhere in the problem. So in this case, they give us the area scale factor because they say that the similar triangles have areas of 49 square centimeters and 16 square centimeters. All right, so that's two areas. If I sort of go small over big, that will be 16 over 49 would be the scale factor. Now, the next thing we want to figure out is what would be the length scale factor, because everything is sort of based on the length scale factor. So in fact, in general, whatever the length scale factor is, you square that, and that's how you get the area scale factor. For example, if the length scale factor, let's say the length scale factor was 3 to 4. Then the area scale factor would be 9 to 16, because we would take the length scale factor and square it, and then that would give us the area scale factor. Okay, on the other hand, the volume scale factor would be achieved by cubing the length scale factor. So if I take this and I cube it, then that would give me the volume scale factor, which would be 27 over 64. All right, so we basically have to ask ourselves, what length scale factor, if you squared it, would give you 16 over 49. So what squared is 16? That would be 4. What squared will give you 49? That would be 7. So the length scale factor must be 4 to 7. Now that I have the length scale factor, I can also use it to find the volume scale factor. If I were to cube these two numbers, that will give me the volume scale factor. So I know 4 cubed is 64. 7 cubed, I'm not 100% sure off the top of my head, so I'm going to check it. 343. Okay, so now we have the length scale factor, the area scale factor, and the volume scale factor. So we should be able to use these to solve the rest of the problem. Okay, now the perimeter of the larger triangle is 39. Find the perimeter of the smaller triangle. All right, so I'm going to call the perimeter of the smaller triangle, I'm going to just call that x, since that's what we're looking for. So I should be able to make a proportion starting with the two perimeters. So the small triangle has perimeter x, and then the larger triangle has perimeter 39. So x over 39 is a ratio of perimeters. Now, in the back of your mind, keep track of the fact that this is the small perimeter, and the 39 is the larger perimeter. All right, so we have small over big. The point of taking note of that is we have to know which number to put on top. So when we talk about perimeter, is perimeter a length, is it an area, or is it a volume? Well, perimeter is a length. You just add up all the sides, and that's where you get the perimeter from. Perimeter would be measured in centimeters or inches or feet. That's a length. So that tells us that we're going to be using the length scale factor for the other side of the proportion, for this second fraction. But sometimes we will do 4 over 7, and other times we will do 7 over 4. Because we're doing small over big, we know to do 4 over 7 in this particular case. So that's how you set it up, and now we will just cross multiply to solve this for x. So when we cross multiply, of course, we multiply this diagonal, and then we multiply this diagonal, and we set those equal to each other. So the yellow diagonal gives us 7x, and the blue diagonal, 4 times 39, I'm going to have to check that out. 4 times 39 is 156. All right, then if I divide both sides by 7, that should give us the final answer. So divided by 7. Okay, so this is a decimal. I'm going to round this to 3 decimal places. 22.286. All right, and perimeter. So this is a length, like we said, so the units would be centimeters. All right, so this should be the answer to number 20. All right, let's practice that again on problem number 21. Okay, the radii of 2 spheres have a 2:5 ratio. All right, let's go ahead and start our length, area, and volume scale factor chart right now. Okay, length, area, and volume. So they gave us the ratio of the radii. Okay, radii is plural of radius, so we're just talking about this length right here. So the radius is a length, so this is a length scale factor. So we're going to put our 2:5 ratio right here. So we can use that to get the area scale factor by squaring each of these. All right, so 2 squared is 4, and 5 squared is 25. Now, we can get the volume scale factor by cubing each one of these. All right, 2 to the 3rd power is 8, and 5 to the 3rd power is 125. All right, so now we have all 3 scale factors. We are ready to solve any problem that they throw at us. Okay, the smaller sphere has a surface area of 36 square feet. What is the surface area of the larger sphere? All right, so we're looking for this, so I'm going to call it x. So when I set up my proportion, I'm going to start with x over 36. Now, remember that in this case, x is the surface area of the larger sphere. So this x is big. And the 36 is the smaller sphere, so the 36 is small. Now, the other fraction will come from one of these three scale factors. Which one of the scale factors am I going to use? Well, we're talking about surface area, so we are going to use the area scale factor. Now, will I do 4 over 25 or will I do 25 over 4? As we mentioned a moment ago, we're doing big over small. So that's why we know to put 25 over 4. So now we will cross multiply to solve for x. So we will multiply the yellow diagonal, and we will multiply the blue diagonal, and we will set those equal to each other. So that will give us 4x equals, and then 36 times 25, 900. And then if we divide both sides by 4, that's going to give us 225. Now, this is area, so don't forget your units, which are square feet, which I will just put feet squared like that. Okay, so 21 part B. For the spheres described above, the volume of the larger sphere is 315 cubic feet. All right, that's the larger sphere. Find the volume of the smaller sphere. All right, so we will call this x because this is what we are looking for. So when I set up my proportion, I'm going to start with x over 315. Now remember, the x is the smaller sphere, so I'm going to label this as small, and the 315 is the larger sphere, so I'm just going to put big. So we're doing small over big. Now, which one of these scale factors am I going to use this time for the other fraction? Well, we are looking for the volume of the smaller sphere. So we're going to use the volume scale factor. So will I do 8 over 125 or will I do 125 over 8? We're doing small over big, so we're going to just leave it as 8 over 125. So now it's time to cross multiply. So we will multiply the yellow diagonal, and we will multiply the blue diagonal, and we will set those equal to each other. So the yellow diagonal gives us 125x equals whatever 8 times 315 is. All right, that's 2,520. And then we will divide both sides by 125. All right, so that is 20.16. And this is volume, so our units will be, well, they say cubic feet, and I will record that as feet cubed. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.